I'm a medical student. This is my understanding of the long-range test. I tried to record a video on this while I was drawing it out, but it took me like 10 minutes, and this should really be like a 45-second video. So this is just explaining what the how the long-range test works. Definitions you'll find online that are kind of, in my opinion, essential are often going to be pretty complicated, but I think it's a relatively simple idea to get. And it's worth just seeing once, not that you need to become a statistician. The notation I'm using or kind of borrowing from is based on this textbook, Introduction to Statistical Learning, which is an excellent book for someone who wants to know how to learn how to apply statistics. It includes more modern methods as well, like machine learning stuff. To me, this is an excellent book. Like this could, if you're interested in any kind of science or data analysis, this could be your lifelong kind of statistical companion to help understand how to use those tools to understand whatever your field is better. We're looking at survival data, which could be survival or time to event curves, but really any data where there's something called censoring, so where you have a little bit of information for a patient or for a subject, but not the whole picture. So maybe that they survived at least 5 years, but then they dropped out of the study. So for censored data. So basically what you do, so this is a typical survival curve just to kind of get you thinking in that bucket. And what you do is you come up with a little plot here of a line, which is just a bunch of data points. It's just a list of 1, 2, 3, 4, what that is for every death event that happens in your study, it's just the running tally of people who died. And then so basically this is, every new point is another person dies, so that tally always goes up. So it's for any study, any data set, this is always going to be the same line, 1, 2, 3, 4, 5. And then you look at your subgroup you want to test for statistical difference, and you basically, for every one of those events, if it's one of your patients in that subgroup, this bumps up a little bit. So this is like a step function, and it's going to be it's always going to be under this curve because it's a subgroup within the overarching group. But then basically you just want to multiply, this is kind of a time sign, you want to prorate your data here to control for the fact that it's a subgroup, so the population is smaller than the overall group. So if there's such a situation where your subgroup is not significantly different, when you prorate this kind of a sort of pseudo survival curve, or this like kind of total running death tally is basically what it is. And it's basically lines up exactly with the overall quote unquote death tally or performance. There's no significant difference. But then if after prorating it, you see, well, actually, basically what this is saying is your subgroup had a higher mortality even when you control for the fact that the subgroup is smaller than the overarching group. And then this is better performance. So they actually account for, proportional to how many people were in the study, your subgroup actually accounted for less of the deaths in the curve. So basically you take sorry, this is an ugly graph, but this is like the data. This is like the squiggly line here. And then this is this like perfect, Q line, like running tally. And basically you just take this data set here, or these data points here, and you take these data points here, and you just make it into a standard distribution, or not a standard distribution, but you just take those data points, this list and that list, and you just convert them into a distribution, and then you just ask the simple question, are these two distributions different? Which I think maybe, I'm not exactly sure like the math behind how they do the test, but it could be just the same math for a t-test or something like that. I think this test does assume like normality of these distributions. Anyway, that's the long-range test. So you can say that it's a test between subgroups for like comparing survival data between subgroups, but I think principally or what it does is it looks at one subgroup and it compares it to the overall group of which that subgroup is a part. But they don't make that distinction when defining this, so I imagine it doesn't matter if you use group 1 or group 2, if you split all the survival data into 2 groups. So it probably is like a more essential definition to just say ultimately it's just testing the difference between group A and all the other people who are not in group A, whether you want to call that group B or what. anyway, don't think too hard about that. That's not as important. But this is just how you calculate it, which hopefully this is helpful. It's relatively simple, and I would say if you're going to do survival analysis and use long range tests, it's worth at least seeing once. So thanks.